This is the EdExcel A-Level Maths Paper 3 covering the mechanics section, and this is from the 2022 series. Question number 1. At time t seconds, where t is greater than 0, a particle p has velocity v meters per second, where v equals 3t squared I subtract 6t to the 1/2 j. For part A, we have to find the speed of p at time t equals 2 seconds. So, for part A of the question, when t is equal to 2, v is equal to 3 multiplied by 2 squared I subtract 6 multiplied by 2 to the 1/2 j. And if we work this out, it turns out we get 12i subtract 6 root 2 j. And so what we need to do is find the speed of p at time t equals 2 seconds. So to find the speed, that's equal to the magnitude of v and so if we work out the magnitude of v, we have 12 squared plus negative 6 root 2 squared, then square rooted. And so working this out, we have the square root of 12 squared plus negative 6 root 2 squared, all square rooted, which is 6 root 6, and as a decimal we end up with 14.7 meters per second, given to 3 significant figures. For part B of the question, we have to find an expression in terms of t, I and j for the acceleration of p at time t seconds where t is greater than 0. For part B of the question, we need to find the acceleration, and that's equal to the derivative of the velocity with respect to time. And so if I differentiate 3t squared, we end up with 6t, that's in the I direction, and if we differentiate negative 6t to the 1/2, we end up with negative 3t to the negative 1/2 in the j direction, and the units, we've got meters per second squared. And now for part C, at time t equals 4 seconds, the position vector of p is I minus 4j meters. We have to find the position vector of p at time t equals 1 second. Well, for part C of the question, to find out the position vector s, that's equal to the integral of velocity with respect to time. So we need to integrate v, so we need to integrate 3t squared I subtract 6t to the 1/2 j. And so if we integrate 3t squared, we end up with t cubed, that's in the I direction, and if I integrate negative 6t to the 1/2, we end up with negative 4t to the 3/2 in the j direction, and then we add on a constant of integration, we'll call it c. Now to find what c is, well, we know that when t equals 4, the position vector of p is I minus 4j. And so when t equals 4, we have I minus 4j equals 4 cubed I subtract 4 multiplied by 4 to the 3/2 j plus c. So I minus 4j is equal to 64I minus 32j plus c. And what we can then conclude is c equals negative 63I plus 28j. And knowing what c is, we can therefore conclude that s is equal to, well, in terms of the i's, we've got t cubed subtract 63, and in terms of the j's, we've got negative 40 to the 3/2 plus 28. So this is what s is, and what we need to do is find the value of s when t equals 1. So when t equals 1, s is equal to 1 cubed subtract 63I plus negative 4 times by 1 to the 3/2 plus 28j. And so what we can conclude from here then is s is equal to negative 62I plus 24j meters. Question number 2. A rough plane is inclined to the horizontal at an angle alpha, where tan alpha equals 3/4. And if that's the case, forming a 3-4-5 right-angled triangle, we can see that sine alpha is 3/5, cos alpha is 4/5, and tan alpha is 3/4. A small block B of mass 5 kilograms is held in equilibrium on the plane by a horizontal force of magnitude x newtons, as we see in figure 1. The force acts in a vertical plane which contains a line of greatest slope of the inclined plane. The block B is modelled as a particle. The magnitude of the normal reaction of the plane on B is 68.6 newtons. Using the model for part A, for the first part we have defined the magnitude of the frictional force acting on B. Well, here is our block. What we have is a weight force acting downwards. That would be 5g. We have the reaction, 68.6 newtons. We have the horizontal force, that would be x newtons. And then we've got the frictional force. Now, we don't know the direction of friction just yet. If the block moves up the slope, friction would act opposite. And if the block moves down the slope, friction would act opposite it. Let's assume the block moves up the slope so that friction opposes the motion of the block, and let's suppose the friction force is given by F. What we need to do is find the magnitude of this frictional force. And so what we can do is resolve parallel and perpendicular to the plane. If we resolve perpendicular, then we have the perpendicular component of the weight, that would be 5g cos alpha, and what we also have is the perpendicular component of this force x, which is x sine alpha, and that would equal the normal reaction, 68.6. Now we need to find out what x is before anything else. So we have 5g multiplied by cos alpha, which is 4/5, plus x times by sine alpha. Now sine alpha, that's given by 3/5, and this is equal to 68.6. Let's attempt to find out what x is. We have 68.6 subtract 5 times by 9.8 multiplied by 4/5, and then if I divide this value by 3/5, it turns out then that x is equal to 49. Now if we resolve parallel, then we have 5g multiplied by sine alpha plus f, and that would equal x multiplied by cos alpha. And so we have 5g multiplied by 3/5 plus f, that's equal to x, which is 49, multiplied by cos alpha, which is 4/5. And from this we can find out what f is. We have 49 multiplied by 4/5, subtract 5 times 9.8 times 3/5, so it turns out f is equal to 9.8, and of course we have newtons. So we have found the magnitude of the frictional force, and then we have to state the direction of the frictional force acting on B. Well, we assumed that friction acts down the plane. F is a positive value, which means it is indeed acting down the plane. If we got a negative F, that would simply mean friction would act up the plane. And so it acts down the plane. Now, the horizontal force of magnitude x newtons is now removed and B moves down the plane. And given that the coefficient of friction between B and the plane is 0.5, we have to find the acceleration of B down the plane. Well, here is a diagram representing the situation. If the block moves down the plane, friction would oppose it, so friction would act up the plane in this case. We would have a new reaction force because there is no external force, and we still have the weight of the block 5g acting vertically downwards. Now we need to find the acceleration. So what we can do is resolve perpendicular and parallel. So if we resolve perpendicular, we have r, which equals 5g cos alpha. So we have r equals 5g multiplied by 4/5. And so if we work out what r is, 5 times 9.8 times by 4/5 is 39.2. So the new reaction force is 39.2 newtons. What we can now do is find the magnitude of the frictional force. We can do this using F equals mu r. So we have F equals mu, which is 0.5, multiplied by r, which is 39.2. So if we work out what F is in this case, then F is equal to 19.6 newtons. And now to find the acceleration, we can use the sum of the forces is equal to the mass times acceleration. And if we resolve parallel to the plane, then we have 5g sine alpha subtract f, that's equal to the mass 5 multiplied by the acceleration. And knowing what sine alpha is, that's 3/5. We have 5g multiplied by 3/5 subtract f, which we know is 19.6. That's equal to 5 multiplied by a. So we have 5 times 9.8 times 3/5 subtract 19.6. So we have 5a equals 9.8, and if I divide this through by 5, we can therefore conclude a is equal to 1.96 meters per second squared. Question number 3. A particle P of mass 4 kilograms is at rest at the point A on a smooth horizontal plane. At time t equals 0, two forces F1 equals 4I minus j newtons and F2 equals lambda I plus mu j newtons, where lambda and mu are constants, are applied to P. Given that P moves in the direction of the vector 3I plus j, we have to show that for part A, lambda minus 3 mu plus 7 equals 0. So, for part A of the question, we have our two forces. We've got our force F1 equals 4I minus j newtons, and we've got this other force, we'll call it F2, that's equal to lambda I plus mu j newtons. Now, what we need to do is recognize that P moves in the direction of the vector 3I plus j, and so therefore the resultant force F would act parallel to this vector. So let's find the resultant force. The resultant force F, that's equal to F1 plus F2. So if we work this out, we have F1, which is 4I minus j, and then we add on to this F2, which is lambda I plus mu j, and so therefore we have the resultant force F equaling lambda plus 4I plus mu minus 1 j. Now, this resultant force F is parallel to 3I plus j, and that's because, if we go back to the question, P moves in this direction. And so, therefore, the ratios of the component will be equal. So we have 3I and 1j. So 3 over 1 will equal lambda plus 4 over mu minus 1. And therefore, we have 3 multiplied by mu minus 1 equals 1 multiplied by lambda plus 4. So 3 mu minus 3 equals lambda plus 4. And therefore, if we rearrange, we can see that lambda minus 3 mu plus 7 equals 0. Now, at time t equals 4 seconds, P passes through the point B. Given that lambda is 2, we have to find the length of AB. Well, for part B, knowing that lambda is equal to 2, with this we can find out what mu is. We have 2 minus 3 mu plus 7 equals 0, and we can solve this, and solving we would find mu is equal to 3. And with this, we can now find out what the resultant force F is. So, with mu equaling 3, this would imply F is equal to lambda plus 4, so that will be 2 plus 4 I plus 3 minus 1 j. And so therefore, the resultant force F, that's equal to 6I plus 2j. And now what we can do is find out the acceleration vector, and from that we can find the velocity vector, and from that we can find the displacement vector. And we can do that first of all by using F equals m times a. So we have 6I plus 2j equals mass, which is 4, times the acceleration. So the acceleration vector is equal to 3 over 2 I plus 1/2 j meters per second squared. So, knowing what A is, we can now find out what V is by integrating with respect to time A. So, we will be integrating with respect to time the vector A and if we work out what this is, we have 3 over 2 t in the I direction plus 1/2 t in the j direction plus some constant of integration c. Now, we know that from the question, it starts at the point A, it's at rest at A, so when t equals 0, v is also equal to 0. And so we have 0 equals 3/2t I plus 1/2 t j plus c, where t is equal to 0. And so we can therefore conclude c is equal to 0. And knowing what c is, we can therefore conclude that v is equal to 3/2t I plus 1/2 j. So the displacement from A to B, which we'll call S, that will equal, well, if we go back to the question, we know that when t equals 4, P passes through the point B. We need to find the length of AB, so we can find that by integrating V between 0 and 4. So if we work this out, we will be integrating between 0 and 4 V, which is 3/2t I plus 1/2 t j. And so working this out, we have 3/4 t squared I plus 1/4 t squared j. And we need to evaluate this between 0 and 4. And so working this out for our upper limit, we would have 3/4 times by 4 squared I plus 1/4 times by 4 squared j. And for our lower limit, we would just have 0. And so therefore the displacement from A to B, that will be given by 12i plus 4j. And therefore the distance AB, that will equal 12 squared plus 4 squared square rooted. And if we work this out, we get 12.6 meters given to 3 significant figures. Question number 4. A uniform rod AB has mass m and length 2a. A particle of mass 2m is attached to the rod at the point C, where AC is 1.5a. The rod rests with its end A on rough horizontal ground. The rod is held in equilibrium at an angle theta to the ground by a light string that is attached to the end B of the rod, and that's what we see here. The string is perpendicular to the rod as we see in figure 2. For part A, we have to explain why the frictional force acting on the rod at A acts horizontally to the right on the diagram. Well, for part A, the ground is horizontal and friction acts along the ground, so must be horizontal. And the only two horizontal forces are friction and the horizontal component of the tension, which acts to the left. And for the horizontal forces to be in equilibrium, friction must act to the right, which means we have a tension over here, and we've got this component of the tension which acts to the left, which means the frictional force must act to the right. And that's what we mean for the forces, the horizontal forces, to be in equilibrium, friction must act to the right. For part B of the question, the tension in the string is T, and we have to show that T equals 2 mg cos theta. Well, here is our diagram, and what we have is a frictional force acting at A. We'll call this frictional force F. We've got the tension in the string. We'll call this tension T. And then we've got the weight of the rod AB that would act through the center. Here we have M, and then we've got the weight of C, which is 2 mg. So if we take moments about A, well, if AB is 2A, half of that will be A. So we have the length A multiplied by the perpendicular force, that will be mg cos theta. And then we have the length AC being 1.5 A, and the perpendicular force will be 2 mg cos theta, and that will equal 2A multiplied by the perpendicular force T, and this is if it's in equilibrium. Now, recognizing that the A's cancel, we have on the left hand side mg cos theta plus, well, here we've got 1.5 times 2, which is 3, and then if I divide that sum by 2, we can therefore conclude the tension is equal to 2 mg cos theta, and that's exactly what we wanted to show. Now, for part C, we are given that cos theta is equal to 3/5. We have to show that the magnitude of the vertical force exerted by the ground on the rod at A is 57 mg over 25. So for part C, if we let x be the vertical force exerted by the ground on the rod, that means here at the point A, we've got this vertical force X. What we need to do is find out what X is. And so therefore, if we resolve vertically, then we have, going upwards, X plus the vertical component of the tension, T cos theta, and that will equal mg plus 2mg. And so therefore, we have X plus T, which is 2mg cos theta, and then we are still multiplying this by cos theta. That will equal 3mg. And so we have X plus 2mg multiplied by cos theta times another cos theta. Now we know that cos theta is 3/5, so we have 3/5 squared equals 3mg. And that's equal to 3mg. So we've got 3/5 squared times 2, and then if I do 3 take away this, we get 57/25 mg. So X, that will equal 57 mg over 25 newtons. For part D of the question, the coefficient of friction between the rod and the ground is mu. Given that the rod is in limiting equilibrium, we have to show that mu is equal to 8/19. Now, if we know that cos theta is 3/5, forming a 3-4-5 right angle triangle, that would imply that sin theta is 4/5. Now, in this part of the question, if we consider what's happening horizontally, then we have F to the right, T sin theta to the left, and because it's in the limiting equilibrium, we can therefore say that F is equal to T sin theta. So we have F equals T, which is 2mg, cos theta multiplied by sin theta. So we have F equals 2mg multiplied by 3/5 multiplied by 4/5. And so therefore, F is equal to, well, here we have 2 times by 3/5 times 4/5. F is equal to 24 mg over 25. Now, because it's in limiting equilibrium, F is equal to mu r. So we have F 24 mg over 25. That's equal to mu multiplied by R, which in this case is X, that's the reaction force, which we found to be 57 mg over 25. And so therefore, we can conclude from here, mu is equal to, well, the 25's cancel on both sides, so we have 24 divided by 57, which is 8 over 19. So mu is equal to 8 over 19. Question number 5. A golf ball is at rest at the point A on horizontal ground. The ball is hit and initially moves at an angle alpha to the ground. The ball first hits the ground at the point B, where AB is 120 meters, as we see in figure 3. The motion of the ball is modelled as that of a particle moving freely under gravity, whose initial speed is u meters per second, and using this model, we have to show that u squared sine alpha cos alpha is equal to 588. Now, for part A, what we will do is, using our SUVATs, use S equals ut plus a half at squared both horizontally and vertically. So, we have S equals ut plus 1/2 at squared. And so if we use this horizontally, then horizontally we've got S, which is 120, and that's equal to the horizontal component. Well, if it sets off with u, then the horizontal component of that will be u cos alpha, and then we multiply this by t, and then a half at squared. Well, horizontally there's no acceleration. Now at this point we can rearrange for t. T is equal to 120 divided by u cos alpha. And if we consider the motion vertically, then the total displacement vertically will be 0, and this will equal the vertical component u sine alpha multiplied by t minus 1/2 times 9.8 times t squared. So we've got 0 equals u sine alpha t minus 4.9 t squared. And we know what t is, that's 120 over u cos alpha. So I've got 0 equals u times sine alpha multiplied by 120 over u cos alpha minus 4.9 multiplied by 120 over u cos alpha squared. So we have 0 equals, well, here we have the u's simplifying to 1. So we have 120 sine alpha over cos alpha minus, now here we've got 4.9 times 120 squared, so that is 70,560 divided by u squared cos squared alpha. So if we rearrange, we have 120 sine alpha over cos alpha equals 70,560 over u squared cos squared alpha. And if I divide this by 120, I get 588. And so sine alpha over cos alpha is equal to 588 over u squared cos squared alpha. And so if we multiply through by u squared cos squared alpha, we have u squared cos squared alpha multiplied by sine alpha over cos alpha. That's equal to 588. And with the cos squared and the cos simplifying to just cos, what we can therefore conclude is u squared multiplied by sine alpha cos alpha, that's equal to 588, and we'll call this equation 1, just in case we need it later on. Now, for part B, the ball reaches a maximum height of 10 meters above the ground, and we have to show that u squared is equal to 1960. Well, here what we can do is use v squared equals u squared plus 2as. So, if we consider v squared equals u squared plus 2as, and we will consider this vertically, then vertically, well, the speed as it hits the ground, well, we don't know what that is, but we know that at this maximum height, the speed is 0. So we have 0 squared equals the vertical component u sine alpha squared plus 2 times minus 9.8 times 10. So we have 0 equals u squared sine squared alpha minus 196. We'll call this 2. And what we need to do is find out what u squared is. So the way we can find out what u squared is, we can do equation, well, what we'll do is we'll rearrange equation 2 here to say that u squared sine squared alpha equals 196. And so therefore, if I call this equation 2, we can do equation 2 divided by equation 1, and doing that, we have u squared times sine squared alpha divided by u squared sine alpha cos alpha, that's equal to 196 divided by 588. Now, what we'd have is sine squared over sine, simplifying to just sine. So we have sine over cos, which is tan. The u squareds cancel. So we have tan alpha equaling, well, 196 over 588, that is equal to 1/3. Now, what we need to do is find out what u squared is. And for us to find out what u squared is, I need to find out what sine alpha is and cos alpha. So if I know that tan alpha is 1/3, what we can do is form a right-angled triangle, such as the one here. We've got 1, 3, and through Pythagoras, root 10, which means that sine alpha is equal to 1 over root 10, and cos alpha is equal to 3 over root 10. And now, what we can do is substitute into equation 2, say. So, we've got u squared multiplied by sine squared, so that will be 1 over root 10 squared. That's equal to 1960. And that would imply that u squared over 10 is equal to 196, which means that u squared is equal to 1960. Now, in a refinement to the model, the effect of air resistance is included. The motion of the ball from A to B is now modelled as that of a particle whose initial speed is v meters per second. This refinement model is used to calculate a value for v. We have to state which is greater, u or v, giving a reason for your answer. So now the difference is, instead of us having u, we've got v instead, and that's taking into account the effect of air resistance. So let's think about which will be greater, u or v. So for part C, v is greater, and that's because to travel the same horizontal distance while being slowed down by air resistance, the initial velocity v must be higher. Now for part D, we have to state one further refinement to the model that would make the model more realistic. Well, for part D, the ball is modelled as being a particle which ignores spin effects and ignores that the edge of the ball hits the ground before the centre of mass. A more realistic model would take into account the size of the ball,